Recording in progress. Recording in progress.
All right, so as I said, so the DNS lab is, this is the DNS Attacks lab. And so it is recording now. Yeah, and so the last one will be DNS Cache Poisoning, which is this one. And in this case, you need to actually put in a record into the DNS server. So here in this one, you don't take down the DNS server. You in fact keep the DNS server doing what it's supposed to be doing. You direct your attack at the DNS server, change the cache, the files in the DNS server. When the client issues the request, it gets a response from the DNS server, but it has been poisoned. You guys understand? So that's the 3 attacks. That's it. That's all you're responsible for. All right. So, and then you, as you can see, then after that, it's got all of these task 7, but we're going to skip everything. Okay. So you can skip everything else. And I really just want you to take a look at some of it. Now you can see here, we've got this Python script, Python Scapy. We usually in the program here, we cover Scapy in another course, the network security course, where you actually are shown Scapy first and spend a lot of time just on that. I don't want to throw this at you just for this problem. Okay, so we're going to take another approach to solving these, which is using another tool. Okay, make sense? If you want to do it with Scapy, you feel free to do it. It's not terribly difficult, but it's not required, okay? Because it's up to you. It's entirely up to you. You'll use this in another, but this does take a little bit of learning, some of it. So I kind of want to, we save it for 455. All right, so so the idea then is these are the 3 attacks. So now we can basically, let me find the diagram here. Right, so in theory, to get the most out of this lab, you should have 3 VMs, right? In theory, right? So you would have a VM for the DNS server, configured with bind 9, 1 DNS client, right? The victim, if you will, another clone of seed VM, all configured, which is what you were required to do by today, and then a 3rd one would be the attacker, which is the bad computer, listening in on the network somehow, and then you're going to do these 3 attacks. Okay, so that's the basic idea here. Now the tool that we're going to use, so now I'm going to start the virtual machine actually. So let me start the VM. And so I'm going to introduce the tool to do these attacks, which is something called NetWalks or NetWag. It may not be installed on your computers. So if it's not installed, you're going to have to do an apt install. So let's start the VM. Okay. All right, so the VM. I'm just starting one, but think about the environment, right? So it's, I mean, technically a terminal could be a VM if you think of it that way. But you need to have at least 2 VMs, right? The DNS server, DNS. So I'll just show you how this should work. Okay, so let's go. Yes. Huh? Yeah, so I'm just using one VM, but I'll discuss kind of how it would work. Okay, so remember, the idea is you need to have one machine configured as a DNS server bind. Remember, that's just required, and you have to follow. That's what we discussed last Thursday, right? You got to do that. That's, this is a Linux course. You're a sysadmin. You got to configure this service and feel confident. I know, you got to spend the time until you feel confident that you've done it correctly. Then you have another VM, which should be configured as a client to use that DNS server. And then after that, you should have tested that they work, right? So that's the issue. What we're doing now is the second part of this, part 2, where we're actually going to conduct the attacks on this, okay? So the tool is called NetWalks, okay? You can see I already have it. If you guys do this, you may not have it. Let me minimize this. You can't see my VM. Right, so hopefully you can see my VM now. Okay, so let me. Right, so then I'm going to navigate to the desktop. I'm not really going to be writing any scripts, but in the right folder, I guess. So NetWalks, this is the command line interface. And then there's also NetWag, which is the GUI interface. And there it is. Not very fancy, but certainly easier, probably. What you do is you have, each attack has a number, and there are many, many network security attacks. We're just going to be using the DNS attacks, okay? And basically the way that it works is you can select an attack and then start building with the parameters. And then here, it's going to start actually crafting the command line version of it. Now you can launch the attack from the GUI, but you can also learn with this how to make them in the command line. You guys see that? I'll give you the commands. I mean, I'm not, but I'm just kind of discussing how it works. Okay? You guys understand? Did you guys try to see if you have this program installed? You have it, it's not installed, right? So then if it's not installed, it should be pretty straightforward. Did this the other day. So let's just, it should be sudo apt install and then netwalks. And I think it installs both. So try this command. If you don't, if you don't, huh? Really? I think this worked for me. I already have it, so it's, yeah, see, it's, that doesn't work. Is any TWOX, yes, sudo apt install netwalks. Okay, do the following then. I already have it, so I don't want to install it. Sometimes when this happens, you should do sudo apt update. Just do that so that it updates the repositories. And then try the command again. Did it work for any of you? How about the rest of you? Did it install? Yes? Okay, it worked, right? Okay, good. So if you have it, then that's, like I said, this is not very difficult to do. You just, the key thing is you have to have bind configured correctly. Okay, so remember, you need to open up Wireshark for all of these. Okay, so let's now read through the problems. Okay, so we can go ahead and read through the problems. Let's go back to the, so I need to switch now to the PDF. And I'll go through this with you guys, but you have to make this work in your own environment. Okay, so you should be seeing the PDF. So part 2, attack on the DNS. So the main objective, so I've read this actually. So let's look at the first one, etc host. This one doesn't even need netwalks or anything like that. That's super easy. Okay, so as I discussed with you guys at some point in the lecture, I said that actually before using DNS server, the machine will search its own etc host file. Do you guys remember that? Yeah, so the host name and IP address pairs in the host file, which is located at /etc hosts, are used for local backup. Okay, they take the preference over remote DNS lookups. Okay, so for example, if there's a following entry in the host file in the user's computer, let's say www.example.com, will be resolved to 1234 if you have. So this is the entry that you need to have in etc host. Okay, we'll take a look at etc host in a second. So that, you know, that's basically what happens, right? So when would this kind of an attack occur? Well, this would happen if your machine has already been hacked. Let's say somebody hacked it, they created a reverse shell into the machine, they had the pseudo privileges, boom. All they have to do is come in here, put in a whole bunch of things like your JP Morgan bank account or something, they put it here and you're going to be redirected. That's it. But they have to compromise your machine. Got it? So that's the idea. Okay, so if attackers have compromised a user's machine, they can modify the host file to redirect the user to a malicious site whenever the user tries to access. Oh, yeah, sorry. Yeah. Yes. It would still say chase.com, right? It's going to go to the URL. Well, it's going to go to the IP that you've specified. Oh, it's going to display. No, it's going to display the real one. Right? That's what it should do. So because when you type the domain, it's going to go to the website. We can test this. I mean, so actually, it's a good thing to do. So let me go in. So we're going to need administrator privileges, sudo nano, etc hosts. Right, there we have it. So I'm going to put in, and notice there's a lot of mappings here. You can just add it at the top probably. So where I'm going to say 1, 2, 3, 4, right? This is also the IP that you should use for the, okay, you can't see. This is also the IP that I want you to use, just so that when I see your screenshots, you know, I can see what's going on, okay? And then, oh, here, and then we're going to say, I'm going to use another account, not Chase exactly. So I'm going to say www.pnw bank. Is that a bank? Okay. Purdue Bank. And this is case sensitive, I think. So watch out. All right, so purduebank.com. We entered this, right? Let's say that this is your bank, but it's got this entry of 1, 2, 3, 4. So now I'm going to go ahead, Control-S-Y, and then I'm going to open up a browser. Okay, and now I'm going to go in here, www.purduebank.com. Huh? Well, no, this is just the victim, actually. This is where this is happening. It's the victim. That's in the victim also. And I know I've skipped a lot of things, but it's just I'm answering his question. Okay, I'll go back to what. So it's not finding it. That's the problem. So we would have to go. All right. So we need to now do another IP, one that actually does exist. So give me an IP that does actually exist. Because this we would be able to see this in Wireshark. We would be able to see this, in TCP dump. But what's a website? Give me an IP that exists, right? Yeah, you're right. 1.1. That's good. All right, 1.1.1.1. Okay. All right, so now I'm going to go. So first of all, this is the first indication. The certificate does not match because the certificate would need to match to the specific IP of the real bank. And here, when it tried to go to this, it didn't authenticate the certificate. You guys see that? The certificate, inside the certificate, when you create the hash of that, it needs to have the IP of the actual bank. And this did not match. So that's the first indication that there's a problem. You guys see that? But you can see the URL actually stayed as you typed it. So the IP does not appear here, but the certificate is not working. Does that make sense? If I open a terminal, we can get another one. So for instance, I'm going to ping PNW, right? It should give us an IP for it. So it is 23. Remember this number. So 23.185. I can actually copy it. So we are going to now come in here, right? And we're going to replace it now with this, right? But we created this mapping for PurdueBank.com, okay? So now I'm going to go ahead and I'm going to refresh and see. Yeah, so what does that say? So the certificate is the thing that is the definite. You might actually hear if the attacker is really trying to steal your credentials, they could create your bank's exact layout and you might get something like that, but the certificate does not check out. Oh, you can try HTTPS, but the certificate should not check out, right? So potential security risk, even less. And again, the thing that's really protecting you here is, so Firefox detected a potential security threat and did not continue to PurdueBank.com. And it's because, as I said, the certificate is not matched. Got it? Any questions? Yeah. So this is the idea. And so the basis of this attack then is to change this parameter. So to change. Yeah. So I'm going to take this out, of course, but that's what you guys have to do. Okay, so if we go back to the document, let's just read through the scenario, the exact scenario. I'm going to go ahead to PDF, and it says, change example.net to 1234. If attackers have compromised a user's machine, they can modify the host file to redirect the user to a malicious site whenever the user tries accessing, the website. Assume that you have already compromised the machine. Please try the technique on bank32.com to any IP address that you choose. It should be noted that etc host is ignored by the dig command, but will take effect on the ping command and the web browser. So I was trying the web browser. You can also try pinging. Got it? Now you had a question in the back. So here, the DNS server is not involved at all, right? Because the etc host file lives in the client's file. Okay, or sorry, the etc host lives in the client machine. So what the attacker wants to do is they just want to target the victim machine, hack it somehow, get into their etc file of the victim, right, which is the client DNS, and then change that mapping. And then once that happens, then basically you prove when you guys do what I need to see as a screenshot is when you ping or go via the browser to, if you ping, for instance, bank32.com, I should see 1, 2, 3, 4. That means it took effect. That's it. Literally, that problem is, that's it. Do you guys understand? Yeah. Well, if you hack it, you have to hack the machine, though. But the problem is pretty straightforward. etc host, you can do any of that. The problem is access control is going to stop you. You have to two things. You have to hack the machine first, get a terminal, and there's ways of doing that, right? You guys in 250, you guys took a program called Metasploit, correct? You guys played with Metasploit, something like that, huh? Oh, you are in 250 right now. Well, then you're going to see it in 250 probably. There's a tool called Metasploit. Metasploit is a whole bunch of scripts in Ruby. Ruby is like Python. And basically what happens is these scripts try to make connections very much like SSH, but they connect to daemons, to ports, right? So now these daemons, if they have a vulnerability, that is to say when the coders wrote the code, they made a mistake, attackers exploit that, right? So, so that's basically the idea, okay? And so then, if they can do that, they can get a shell, a terminal. You'll see that in 250 and 450. You'll learn how that actually works. Yeah. So that's the first thing. That's one attack to get the terminal. The other attack is simply if you're a disgruntled employee, you create an administrator account before you leave the company, and then you hack back in. H.D. Moore. No, we didn't do that in this class. But H.D. Moore case, the idea was just people use easy passwords, and so guessing the password, right? Password cracking, as it's called. All right. So yeah. So once that's done, getting the terminal, then you want to get into this file. Now, keep in mind to get into this file. If I go to the VM. If I go into this file, notice I had to use sudo to modify it. So it's not just about getting any account. You have to get an administrator, high privileges account. You guys see that? Make sense? All right. That's the first problem. Not very difficult. Any questions on the first problem before we move on to the second one? Nope. All right, so let's move on to the second problem then. This one does actually, technically, this one does not require DNS server either. Your bind DNS server, only the last one requires. Actually, in this one, the scenario would be, unless actually we might have a graph in the document. So let's go over there. So we've done this one over here. So you should be looking at the PDF. So now directly spoofing response to the user. So in network security, the keywords for sniffing and spoofing. Sniffing means looking at a packet, like sniffing the packet, right? Spoofing means grabbing a packet, sniffing it, which means, like making a copy of it, making a copy of the packet, and then spoofing it, which basically means changing some values in the packet, sending it back out. But it keeps some of the original information so that your ultimate goal is, think of it, an oversimplification, but let's say that machine has a serial number, sends out a packet with that serial number. You grab the packet, keep that serial number, just change some value, send it back. When it receives it, oh, there's my serial number, it's my packet. You guys see that? That's kind of very simplistic intuition. So yeah, so in this scenario, it's actually pretty straightforward. You have this environment over here as a type of a local area network. And then you have a local DNS server, right? A local DNS server. And this is obviously the global DNS servers on the internet. The attacker is somehow in here, right? And then you have some user machines. So this is a client machine that uses DNS, and this is a DNS server. So the user client gets some domain, bank32.com. It doesn't know it, so it would send a query. These are the things that you need to view in. These are the things that you need to view in Wireshark. It would send a query to the DNS server, which has bind, and then bind would reply with the information, the IP. So it's almost like, who is bank32.com? Bank32 is this IP, 21111. You guys see that? And so that would be it, right? And then, but in this scenario, this one, the second one, 3.2, you need to, basically, you would take out the DNS server. How do you take out a DNS server? Denial of service attack, for instance, something like that, right? So you would take it out. The DNS server is too busy to respond. And so that way it gives you time to capture a packet and reply before the DNS server can reply. That's basically it. So again, you would try to go to a fake place. You guys see that? That's the scenario. So let's read through it. In this attack, the victim machine has not been compromised. So attackers cannot directly change the DNS query process on the victim machine. However, if attackers are on the same local area network as the victim, they can still achieve great damage. So when a user types the name of a website, a host name such as example.net, in a browser, the user computer will issue a DNS request to the DNS server to resolve the IP address of the local host name. After hearing this DNS request, the attackers can spoof a fake DNS response. Remember that packet is in the network, right? So the attacker just needs to find it, tap into the line, sniff it, basically. So the user's computer will issue a DNS request to the DNS server to resolve the IP. After hearing this DNS request, the attacker can spoof a fake DNS response. The fake DNS response will be accepted by the user's computer if it meets the following criteria. So that's why it has to actually sniff and spoof. So it doesn't want to create it from scratch, although it could. It's better, imagine this is the packet, this is the attacker here. It scans it, copies the whole thing, creates a new one, changes some fields, but leaves other fields as they were, sends it back out. Because the real DNS server is down, it'll receive it. If everything checks out, it'll just process. You guys see that? And that's the logic. And as I said, and this is just our objective is to understand this. So the fake DNS response will be accepted by the user's computer if it meets the following criteria. So here are the things that it's going to look for. The source IP address must match the IP address of the DNS server. So we just need to change that, right? We know that. The destination IP address must match the IP address of the user's machine. We know that. The source port number, a UDP port, must match the port number that the DNS request was sent to, usually port 53. It can just get that because it's copying all these values originally. The destination port number must match the port number that the DNS request was sent from. It can get that as well. The UDP checksum must be correctly calculated. The transaction ID must match the transaction ID in the DNS request. The domain name in the question section of the reply must match the domain name in the question section of the request. All of that can be copied. The domain name in the answer section must match the domain name in the question section of the DNS request. The user's computer must receive the attacker's DNS reply before it receives the legitimate DNS response. Notice that you might say, well, isn't it encrypted? If this works for you, it's not. You guys see that? So you'll see in this, you'll be able to scan it in clear text. right? To satisfy the criteria in 1 to 8, the attacker can sniff the DNS request message sent by the victim. They can then create a fake DNS response, send back to the victim before the real DNS server does. Here, as I said, we're going to use this tool, NetWalks, which I think you've installed. Remember, it works on numbers. So the number for a DNS attack is 105. All right, and you can see the syntax basically is down here. And I'll provide like an example of a complete one. So the NetWalks tool 105 provides a utility to conduct such sniffing and responding. Okay. We can make up any arbitrary DNS answer in the reply packets. Moreover, we can use the filter field to specify what kind of packets to sniff. For example, by using source host 10.0218. We can limit the scope of our sniffing to packets only from that IP. So here is the tool. This is called the sniff and send DNS answers function from NetWalks. So it's NetWalks 105. And then we have these parameters, which you can see is that these are the flags. Anything with a little dash is a flag. And then this is the value associated with that flag. So we've got like the IP, the data that we're sending, several IPs, so the source and destination, a filter if you want, and some additional parameters. So as I said, you can read through this and play with it, and I encourage you to play with it. I'll provide an example of one that should work. Well, the key thing is you kind of have to start this first, right? So because it has to sniff a packet. So you have to kind of start it on the attacker machine. And then when the client makes the DNS query, right, it has to be sniffed by the attacker. Remember that in our environment, in our virtual environment, virtualization environment, it's kind of like a hub. So everybody listens to everyone's packets. In a switch environment, we might have to tap into a line or something with a network tap. But at the end of the day, that can be done too. So while the attack program is running on the user machine, you can run dig command on behalf of the user. This command triggers the user machine to send out a DNS query to the local DNS server, which will eventually send out a DNS query to authoritative name servers, for example, .net, if the cache is not on the DNS server. If your attack is successful, you should be able to see your spoof information in the reply. Compare your results. And so the key is, when you do that dig command for whoisexample32.com, right? You send it out. The attacker will respond. In the response, I need to see what the attacker IP is. So for instance, you might say, not the attacker's IP, but the entry for that DNS entry. So let's say, again, just use 1234. That will be easy for me to look at your screenshot and know, okay, they did it correctly. Does that make sense? Okay. So make sure that in your attack, you put in that value. Okay. Put in that value. Yeah. Yeah. Sudo apt or sudo apt-get, either one. Probably sudo apt. You tried sudo update and then it worked? And it worked? Okay, great. Perfect. Any other questions, guys? All right, so let's switch over to the machine. Now, how does this one work? If you have the 3 VMs, DNS server, you don't have to do a denial of service attack on DNS server, right? Just turn it off. Just turn off the machine. No need to do that part. You have then the client, and then you have the attacker. On the attacker, you run the netwalks command first, netwalks 105 with the flag. It's going to kind of like hang there in the terminal. And then from the client, you issue either the dig command or something, a ping command. When you do that with the domain name, you should see a response, and the response should be 1234. The only way it could have gotten that is from the netwalks. Make sure when you do this, because you did in the first problem, the etc, make sure you remove this entry, correct? Otherwise, it will always be doing this. Actually, let's do this. For problem 3.1, use 1234. For problem 3.2, use 5, 6, 7, 8, so that there's no confusion. Okay, because you would have to remove this entry, but otherwise, if it finds this entry, it will always reply 1, 2, 3, 4. You will think that it worked, but actually it didn't. Does this make sense? Okay, great. So this is this example. So now let's switch over to the virtual machine. Yes, exactly. Ping works. Yes. And make, in particular, screenshots that show that you did it correctly. Okay. All right. So let's go to the virtual machine now. Okay, so I'm going to do. All right, so remember, you are in the attacker machine. You've taken down the DNS server, right? And the client is your target. You need to get the IPs for that. So the command should be as follows. From the attacker, first, from the attacker, you would type, you should all be seeing the VM. From the attacker, you would type sudo, because you need to type sudo again, because you need to grab the interface, and because you're going to be manipulating packets, you need sudo permissions. Okay, you're going to be sending things out into the network, so there's got to be controlled somehow. So sudo netwalks 105-H, and then you have to put in here the domain name, basically. So let's say I'm just gonna say example.com. Then you put in the IP -H, which would be in double quotes actually for this problem we said 5.6.7.8, right? Something that doesn't exist, but it's not 1, 2, 3, 4. So any combination is fine, just to, there's no confusion between this problem and the first. -A, the DNS server name that you configure, because it's got to have that parameter that it's coming from that DNS server. So that should be, depending on how you configured it, ns dot and then here example.com. Okay, but just make sure this matches your bind configuration. Then -A, uppercase A, and then this should be so now this is going to be an IP address. So let me just put in 192.168 dot 127.152. This should be the IP of the DNS server. Okay. The actual bind server that you configure, that should be it. 192.168.127. I mean, obviously not this number, but your own in your own environment. You guys see that? But it should be the IP, whatever it is, of your setup. The bind one, the DNS server, the one that has bind that the client is using as a DNS server, that's this. No, the PDF IPs are generic. So you should follow the instructions, but those IPs are for whatever environment they had when they created the document. in your own NAT configuration, you may have other IPs. Instead of changing your whole environment to match the PDF, it's probably easier to leave your own environment and then just in the configuration files, change it to match your network IDs. Do you understand? Is that clear for everyone? All right. So we do this one, 152, then -D, and this is going to be the interface. Okay. So in this case is whatever, I think this is what is the interface of these VMs, like ENP something, right? So just find the interface. I'll just put in ETH0 here, but it should be the interface of your VM, of the one that actually you're using, okay? And then finally, all you need is the filter, so -F, and that should be the filter of the client machine. The client machine is the one that's going to be issuing the query, right? So in this case, you would say filter where source host is 192.168. I'm just putting in some IP here, 127.154. Obviously not this IP, but the IP of your client, your DNS client. That's it. This is the command that you run on the attacker. You run this, then on the client, the victim, you go in and issue a ping request or a dig command. When that packet goes out, attacker will capture it, it'll sniff it, and then spoof a copy, send it back to client, and then client should get the wrong information. Yes. This is the victim's IP. That is correct, because this is the filter that says only respond to packets from this one. So you're targeting the victim. Because there could be multiple machines issuing DNS queries, right? And you just want to target. In your environment, you probably won't have that. But still. You could, I mean, yeah, I see what you're saying. You could probably do that. You could also, just with this formatting, just open several terminals, each one targeting a different IP. That would also work. They're all going to be listening. So I'm sure you can. I mean, you just have to dig in. So then, to test this, what you could do is, so everyone got this command, correct? Everyone got this command? My error is I don't have that device. So ETH0 is not the device of this machine. The device is ENP0S3. I didn't know that one. So ENP0S3. I'll give it to you in a second. So you can see the terminal is just hanging them. You see that? That means it's currently sniffing the network. It's waiting for somebody to issue the example command. So if I opened another terminal, now assume this is on the victim machine. I'm just going to, you could use dig. You can also just ping. What is it? www.example.com. Oh, yeah. My filter is incorrect, right? So my filter would have to be, yeah, that machine. So this machine is, oh, and also to answer your question. So I'm going to do both things. If config gives me ENP 0S3 and also 10.0.2.15, which is actually the IP of this machine. So 10.0.2.15. So then I would have to go here. I'm going to kill this one. And this should be 10.0.2.15. Okay, so now I'm going to try this again. So here you can see it actually sniff the packet. But it's not providing the response. This is still 3.2. 3.2. Trying to see. Because it's not necessary, I think, for this to be from one VM to the other. It should still work from terminal to terminal. It's I can see here that it issued a packet. So let me try another. I'll do example.net here. Oh, there it is. There it is. You guys see that? So it did work this time. So I got 5767 with the dig command. It's a good question. We'll take a look. I think because it's the built-in for the VM DNS, and that might be the issue. So, so let's see. Let's try ping. There's something in the PDF. We'll take a look. So, example. So hold on. Everyone should be seeing the VM now. Okay. I'm gonna do .NET, and I'm getting 5678. You guys see that? So 5678 is the one that I'm supposed to get, and that happened over here. And here you can see it was issued as 5678. Does this make sense, guys? If we go back to the PDF, it said something. I remember. There it is. This is the explanation. So we will launch a series of DNS attacks on the example.net domain. It should be noted that we are using example.net as our target domain, not example.com, which is what I was using. The latter one, example.com, is already hosted in our local DNS server in the setup itself. So no DNS query would be sent, and that's why it wouldn't work. You guys see that? So if we try bank32.com, I think that was the other one that it wanted us to try. But then we have to specify that also in the VM, right? Wouldn't you think? So then I'm going to do bank32.com. Okay, run that one. And then I'm going to here, clear bank32.com. So this one. Okay. Is that in the, well, let me take a look at it. See. I don't see it here. Let's go back to the PDF. Says here, assume that you have already compromised a machine. Please try this technique to redirect to bank32.com to any IP address that you choose. Try another one. Sudo networks 105. Mm-hmm. That's a good observation, actually. Yeah, let's try that. So bank32.com. Let's do this one, bank32.com. Why not? This is what we want. This IP is the one that I'm not 100% sure. I don't think it matters because I think this, but let's try that. Okay. I'm going to do bank 32. It doesn't matter. So it issues so it receives it, it captures it for sure. Query, DNS question, but it gets an actual response. And it's an IP. You know what I think it is? You know what I think it is? Bank 32 is giving me an IP, right? What was the IP of it? 34102. It's getting that from the internet. I think the real DNS query is coming in faster than the attack query. Yeah, I think that's what it is. I think that's the issue. So it's apparent. Is there a Bank 32 website? Does that exist? Let me see that. The domain exists, that there's an entry. Well, let's make up something that may not exist, right? So I think that's what it is, because that's why you have to take down the DNS server, right? Because otherwise you're gonna get a response and they come in pretty quickly. So to prove that, let's make up one. Can't possibly exist. For the Calix Bank 32, my own bank. All right, so let's see if this cannot exist at all. 3200. Okay, so this should take longer, I would think. All right, now let's go over here. So this is running. Oh, the ping was no, the ping's not running. So this is going to be. See, there it is. 5678. Do you guys see that? In this case, and what's happening is it's not that it only works for non-existing domains, is that it's the speed issue. A real is coming pretty fast. And so that's why the problem says this actually proves very well that you have to take out the DNS server of that client. So that client is using a specific DNS server. You have to take it down so that it doesn't have anything. And it's almost like a race condition where you have to go really fast and win the race. So that should be problem 3.2. Pretty much what I did, just do it with your own VMs. Does this make sense to everyone? Clear. All right, perfect. The last one is probably a little bit harder. That's 3.3, because now you definitely need bind. Okay, you definitely need bind. You can test it the same ways with dig or ping, but now you have to what is called poison the cache. Okay, so you'll have to poison or cache poisoning. So as you can see, the name is literally DNS Cache Poisoning attack. So let's go over here and take a read through. Okay, so it says here, DNS cache poisoning attack. The above attack targets the user's machine. In order to achieve long-lasting effect, every time the user machine sends out a DNS query for www.example.net, the attacker's machine must send out a spoofed DNS response. This might not be so efficient. There's a much better way to conduct this attack by targeting the DNS server instead of the user machine. When a DNS server, Apollo, receives a query, if the host name is not within Apollo's domain, it will ask other DNS servers to get the host name resolved. So the DNS server now is going to make a query. This is not a query of the client, but a query of the DNS server. Do you guys see that? So it will ask other DNS servers to get the host name resolved. Note that in our lab setup, the domain of our DNS server is example.com. Therefore, for the DNS queries of other domains, the DNS server Apollo will ask other DNS servers. However, before Apollo asks other DNS servers, it first looks for the answers from its own cache. If the answer is there, the DNS server Apollo will simply reply with the information from its cache, that entry. That's what you guys need to do. You need to poison that. If the answer is not in the cache, the DNS server will try to get the answer from other DNS servers. When Apollo gets the answer, it will store the answer in the cache. So next time, there is no need to ask other DNS servers. All right, and so basically here, you can see these are all the instructions. I'll let you guys read through it and kind of work through this one. I will just provide the entry as well. So let's switch over to the virtual machine. So this would be for the next problem, right? We would need to in this task, we need to use netwalks to spoof a DNS response to the DNS server. So the way this works is the command basically, sudo netwalks -h. And then here, you need to provide an entry, right, as well. So let's make it kind of more fun this time and do google.com. So google.com. Okay, so sudo netwalks 105-h google.com. The entry now -h should be another number that doesn't interfere with the other one. So what would be a good one? So let's go backwards, right? 9876. Just make sure that these don't exist, right? That's all I want, but use different ones. You get the idea. -a. This should not matter, but let's just do ns.google.com. Keep it consistent. This also should not matter. So you can probably even do the same number, 9. Okay. Then we need the interface. I think my battery is really low. Just the brightness. All right, so -d, we were saying, what was it? DNS what? You guys remember? DNS P03 something? I don't remember. Let's just say that. Okay, looks about right. If you notice, it's very similar, right? It's very similar to the other one. ENP03, thank you. S3. All right. We need the filter. And that's just going to be source host. And then, you know, whatever the IP was. I think it was like 10.0.2.5. Can't remember. And then here, we just want to say S raw. These are the new parameters, -T, because this is specific to the DNS server, the way it works, timeouts and everything. And that should be it. So if you notice, it's very similar. Just remember, this is a query from the DNS server to other DNS servers. And so now the attacker is going to spoof pretending to be an authoritative DNS server and provide the entry. And then the entry will be cached in the DNS server. So for this one, you definitely need to have bind working. Just want to confirm that I have everything. Give me a sec. I'm just confirming. Yeah, go ahead. Yes. This is actually of the attacker, because this is the attack. The attacker is creating here some kind of a process that is listening on the network on that interface. You know, and it's in what is called promiscuous mode, which basically means any packet that gets in there, it's going to sniff, basically, and based on that filter. So what it's going to do now, though, it's going to issue responses pretending to be an authoritative DNS server. Got it? Yes, sir. Yes, 600. Yes, that is correct. So let me, if I hit enter, oh, yeah, of course. I'm missing the number itself. I need to tell it which attack to do. So in this case, it should be 105. Okay, same number. See, now it's working. This is on the attacker machine. Now, the scenario is you need to have both the DNS client, DNS server, they need to be up and running. DNS client now needs to make the query to DNS server. DNS server then will try to find out what it is. Attacker needs to sniff that, spoof, poison the cache, and then that's it. You can once again test this. So obviously I don't have bind here, so you can test this with same thing. You would do ping www.google.com, and you're not going to get Google's IP, but you should get whatever that entry was. Okay, guys? And that's the last problem. All right, so that's basically it. As far as like kind of a demonstration, I pretty much covered everything except the last part, which I leave it to you to solve, given that you've configured bind correctly. It won't work until your bind setup is correct. Okay. So let me go ahead. I'm going to stop the recording now. And if you have any questions or anything, otherwise just work on the lab, today's lab. So work on it. So I'm going to go ahead and stop sharing. I'm going to pause.